Lesson 6.g.4, you're going to learn to represent 3D figures, three-dimensional figures, with nets, and use the nets to find surface area. So what's a net? A net's a flat picture of a 3D shape. So if you look over to the right, that's a cube. That's the net of a cube. It's basically if the figure was made of cardboard and you unfolded it, it would look like this net. Notice that a cube has 1, 2, 3, and then 3 more sides, 4, 5, 6. Has 6 faces, and so does the net. Every face is represented by a flat figure. Okay, so that gets us to the next set of vocabulary. You need to know what a face is, you need to know what an edge is, and you need to know what a vertex is. So the face is a flat surface. A rectangular prism like the shape we have drawn here has 6 faces. Different shapes have different number of faces. An edge is where 2 faces come together. For your notes, just draw this picture and label the different parts. So an edge is where 2 faces come together. So this shape has 1, 2, 3. There's another edge you can't see back in the back here. 4, 5, 6, 7, 8, 9, 10, 11. Has 12 edges. Okay. A vertex is a corner. It's where all of the faces and edges come together. So, surface area, the next term. It's the sum of all the faces of an object. I meant the sum of the areas of the faces. So remember, area means the number of square units. So the area of this front face is 6 because there's 6 square units. The area of the right face is 4 because there's 4 square units. So that's what we're talking about when we say surface area. Add up the area of all the faces. Okay, so an example. Find the surface area of a rectangular prism with length 3, width 2, and height 2. Use a net to help. Okay, so that rectangular prism that I just described is that one. Length 3, width 2, and height 2. So now we're going to use a net. We're going to use a 2-dimensional representation of it. We're going to take that shape and unfold it. So this face right here that I'm highlighting in blue would be the front face. And the top face would be this face. So all of those long rectangular faces are right here. And the 2 end faces are right there. So that's a net. So that's showing all of the faces laid out flat. And now I'm going to label the dimensions. So if I look, these are all 3 wide. So it's 3, and they're all 2 tall. They're all 2 tall. So that's 2, and all of the edges of the side faces are 2, so it's 2 by 2. And that will pretty much do it. So now I can use my net to find the surface area of the whole thing. So I'm going to put the surface area in black. I'll put it in blue. The surface, or the area of the front face is 3 times 2, which equals 6. So the area of the front face is 6. This face is also 6. These are all the same dimensions, so they're the same area. So I have 4 6s. That would be 24. And the area of the end faces are 2 times 2, which is 4. So I have 2 4s. Those add up to 8. And so 24 plus 8 is 32. So the surface area of the rectangular prism is 32 square units. Make sure that example gets into your notes. Here are some extra examples. Brady's drawing a net of a triangular pyramid. Nice. Which statement's correct? So triangular pyramid means the bottom face is a triangle and it comes to a point up above. So that would be a triangular pyramid. Which statement's correct? Well, his net should have 5 faces. His net does not have 5 faces. It has a bottom face, which is a triangle, and then it has 3 faces, one coming off of each of those bottom edges. So one in the back, another one in the back, and then one in the front. So there are 4 faces, not 5. Another way to say it is there's a face coming up off of each edge. So that bottom edge, there's a front face right there. There's a face on the back right there, and there's another face on the back left. So that's 3 faces, and then there's the bottom face. Okay. The base of his net should be a triangle? Absolutely. When you name pyramids, you name them by their base. His net should have 2 triangles for bases. It's a pyramid, so it comes to a point. Now, we haven't talked about that, but all pyramids come to a point. They don't have a bottom and a top base. The lateral faces of his net should be rectangles. The lateral faces are the side faces, and they're not rectangles. They're all triangles. The lateral faces of pyramids are triangles. So that's the only correct answer. Next, Evan is drawing a net of a cube. How many squares should she draw? A cube is like dice, and dice have how many sides? They have 6. So you could see them all if you draw a cube like this. 2 squares, connect the edges, and you have 4 going around the side. 1, 2, 3, 4, and then you have a front and a back. 5, 6. Next question. A storage unit is in the shape of a cube with 8-foot edge lengths. What's the surface area of the storage unit? Now, cubes are especially easy to find the surface area of because all of their faces are the same. They're all squares, identical, congruent squares. And this one is an 8 by 8. So the area of the front face is 64. And there are 6 faces on a cube. So 64 times 6 is 384. 384 square feet. If you add up all the faces. 64 on each of them. Make sense? I hope so. Part 2. Determine whether each statement is true or false. If the length of each edge of a cube is doubled, the surface area will increase 2 times. That is not true. If the length of each edge is doubled, every face is going to be 4 times as big. What I mean is, if I double the length and the width, the length of each edge, yeah. So if I double the length of each edge, each face becomes 4 times as big. So the surface area is going to be 4 times as big. So that is false. If the length of each edge of the cube is cut in half, the surface area will be 1/4 of the original. That's true. Look at the drawing that I had made before. If I take an original square face of a cube and I cut it into fourths, well, that would be cutting each edge in half. This edge would be half as long, this edge would be half as long, so I'd be left with that as the size of my cube, so that's 1/4 the area of the front face, and I'd have 1/4 of every face. So that is true. Next one, if the length of each edge of a cube is tripled, the surface area will increase by 9 times. Absolutely. If I triple each edge, I got 1, 2, 1, 2. It's going to look like this. If I triple each edge is 3 times as long, the area would be 9 times as much. And that's on the front face, and it would be the same on every face. So that's true. If the length of each edge of a cube is cut by 2/3, the surface area will be 1/3 of the original surface area. Not true. If the length of each edge of a cube is cut by 2/3, I would be cutting off 2/3 of this and 2/3 of this. Each edge would be cut by 2/3, that leaves 1/3. That means that each edge would be 1/9, or each face would be 1/9 the size that it was originally. So not 1/3. That's false. So you can see you're going to need to think through these questions. Now it's your turn. The quick check, find the surface area of a cube with side length 3. Use a net to help. You have to draw the net to get this checked off. Good luck. See you soon.